So we have here Professor Folman from the physics department. He's doing quantum physics. I was checking your CV last night and saying, yeah, it's quite impressive. Founder of BGU Center for Quantum Science and Technology. That sounds really nice. And the first director of the Nano Fabrication Center as well. So very nice. So please, Ron.
Thank you. Okay, it's great to be here. You want me to have a microphone or?
Yes.
Yeah.
Okay.
1, 2.
Ah, this kind of microphone. Yes. Okay. So, Ute, thank you for the invitation. It's an interesting topic, and I had fun thinking about it. And I'll share with you a little bit my thoughts. So the title, as you see, is Dangers of Applied Science for Fundamental Science. And I wrote here from the perspective of the eye of the quantum technology storm. Really, we are in the middle of the storm, the eye of the hurricane. Right now, there is a hurricane in quantum technology. You all hear about every few weeks another quantum computing company being set up. My students, they are all being targeted directly. They're getting phone calls. Leave the university, come and work in the industry with huge salaries. It's crazy what is going on. And my former students are doing that. My former students are taking my students to go and work in the industry. So it's kind of a crazy situation. So it's really, I'm reporting from the eye of the storm. Okay, so you see the winds around. Okay, and already on the first slide you see the tension that we are living under. Because here what I put is the funding agencies. By the way, we're called the Atom Chip Group. If you ever want to go to our website, just do Atom Chip BGU and you'll find us. So the funding agencies that you see here are all funding agencies for fundamental science. Okay? And that's great. But you see here also these two. So these are governmental. These three are governmental, you might say. This is from Brussels, European government, from German government, from the Israeli government. But you see more and more private foundations. And why? Because these governmental foundations or funding agencies that are getting their money from the governments, as we just heard about what's happening in the US, they are under more and more pressure, I would say, to also think about technology, think about creating jobs and all kinds of things like that. And private funding agencies are coming online to try and really go even deeper into high-risk, high-gain projects. And by that I mean look far into fundamental research. With no special application in mind. And you also have these kind of funding agencies that are from the start just interested in technology and jobs. For example, Innovation Authority is interested in applications, technological applications of us from the Ministry of Defense. VCs, venture capital, of course, is interested in that, and the industry itself. So you have a wide range of funding agencies, each interested in a different point on this spectrum. And research groups like us, we have to really decide what we are willing to do, where we want to be on this spectrum, and sometimes even avoid taking money, because it takes us too far from our comfort zone on that spectrum between applied science and fundamental research. Okay, so a few words about how an experimental group in quantum technology looks like. So there's a lot of money now in quantum technology, so the groups typically around the world are big groups relative to normal research groups in universities. So our group is something like 25 people. Plus another 25 people in the fabrication facility. The battery of this is going out, but okay. So fabrication facility is a place, clean rooms, people are like dressed like in Intel, where they're doing quantum chips, which we need. We're also supplying quantum chips worldwide, and 25 people are working inside the lab. We have about 10 experiments going on, and we really try to keep a balance, 50-50 balance between fundamental and the applicative science, and it's getting harder and harder because everybody in quantum technology now, including governments, they want a quantum computer, they want quantum cryptography, they want all the great disruptive technology that are being promised in the quantum world. Okay, atomic clocks, great magnetic sensors, and so on. So it's getting harder and harder in this field to maintain this balance. Here is how this balance looks like. On the left side, you see things that we do in fundamental science. For example, we search for dark matter. Yeah. Right now, it's very fundamental. There is no application for it. Or we split a clock into two places at the same time. The same clock is in two places at the same time to study Einstein's general relativity. Right now, there is no clear application for that. So this is fundamental science. And on the other side, you see a very applicative science. For example, this is an atomic magnetic sensor that we did for the Israeli aerospace industry. For a company called Acubit, we built the next generation of atomic clocks for Israel. This is very applicative, you know, for example, that the Iron Dome would not work if there would not be atomic clocks in the system. So, okay, and we even do practical technology work for the US Navy, US Air Force, and so on. Okay, so this balance is hard to maintain, as I noted. And let me give you one example, specific example. I already showed this picture. Can you change the battery, maybe?
I think this is a regulatory thing, that the laser cannot be stronger than this specific intensity. Because I've changed the battery.
Yeah, okay. So anyway, this is, I showed you before, it's a very small, there are atoms here. There's a glass cell here, and there's a vapor of atoms inside, the fiber coming in, fiber going out. This is a very sensitive atomic magnetic sensor. It could do many things, including, by the way, scan the brain, so to replace the MRI and the CT that are very, very expensive and sometimes don't work well because a lot of radiation or magnetic fields that people with pacemakers cannot use, and so on. Every neuron that fires actually makes a magnetic field because it's an electrical current, and there's a halo magnetic field around the brain, and these atomic magnetic sensors are sensitive enough. So several companies around the world are actually building helmets. In these helmets there are these sensors, and you are going to be able to map the brain according to the magnetic field of the brain. So for example, the Israeli aerospace industry wants it for all kinds of things, not only medical applications, but of course also homeland security applications. And here we also did something, we imaged with these with tiny magnetic sensors, the magnetic fields from vortices in superconducting materials. Everybody's dreaming of room temperature superconductors because we're losing a lot of energy on all of these high voltage wires that you see outside on the poles. A lot of energy is lost there, but once people manage to do room temperature superconductors, and these vortices will teach us how to do it, then we'll have to do much less energy. We'll have to produce much less energy, okay? But then, this is completely applicative. But we want to use the same knowledge about magnetic sensors, and so we also use these magnetic sensors to look at events in which strange things cross to Earth. This is called the domain wall of dark matter. It's a paper we published recently about such a search for a wall of dark matter that crosses through Earth. Okay, so even with the same system, we try to do fundamental science, and we try to do applicative science. Okay. So the standard way of contributing to technology is just through the students. You know that one of the main topics of the university is education. We educate not only in first degree, but mainly in second degree and third degree, and then we send the students to the industry. And our students are part of this quantum technology hurricane that I described. So just to give you examples of Israeli companies, This company, Quantum Art, already something like $25 million in seed money, was founded by one of our PhD students, former PhD students, yeah, Tal David. This company, photonic quantum computing, one of the lead researchers there is also a former student of ours, and so on in many other Israeli companies that do quantum technology. Our students are leading the way. So this was the standard way of helping applicative science, but now things are changing, okay? Things are changing, and I want to describe to you how they're changing through several topics. First of all, I want to discuss exploit versus explore. Many people like to talk about the brain having these two completely different functions. One is to exploit. Here we know the rules of the game, and we want to exploit them for our interest, to get more food, to get more money, to get more something, and this is exploit. It's a problem that needs to be solved with logical thought. On the other hand, there is exploit. Exploit is a completely different thing. Exploit has a random seed in it, because if the typical way of doing things is A, now you want to think about B and C and D. These are different options, and this is called explore. And I claim that the difference between applicative science and fundamental science is really the difference between explore and exploit. Applicative science knows the rules of the game and tries now to exploit them. For example, we know quantum mechanics, we know the Schrödinger equation, we now try to exploit it to build a quantum computer. That's exploiting.
Yeah.
And it's almost an engineering problem. But explore is now to try and think, okay, how will the universe end? Will it end again with a big bang? Will it continue to expand? Is there dark matter? Is there dark energy? What drives? Is there determinism in our brain? Are we a machine? That's to explore. These are questions that right now have no applicative angle to them, and they don't give us any angle of exploitation. We can't exploit it for anything, any interest that we have. Okay? So this, for me, the difference between applicative science and fundamental science is really the difference between explore and exploit. Another thing is that it's actually connected to this explore and exploit, is that science, of course, cannot work without truthful reporting. If you're not objective, it's very hard to do science. And if the whole community doesn't become is not objective, science will go down the drain. And the fact that we try to exploit through funding from industry. Industry is interested in what's going to be the profit in 2-3 years. It's already biasing, there's research being done about that, it's already biasing the way scientists are reporting. And that's a really big danger for science. So you can find online quite a bit, even from the NIH, a big organization, that says that industry sponsorship is a key source of bias that can affect research in multiple stages. This is very, very dangerous for the scientific community. Okay, the second issue I want to address is the chasm, or the big tehom in Hebrew, between technology and the humanities. Now, what's the connection to this talk, this chasm between the humanities and technology? Well, I claim there is a big connection, because the fact that these two communities, or these two cultures, as was called by in the famous book of C.P. Snow, they don't talk to each other so much. This is part of the problem of humanity. Okay, humanity, if these two cultures don't talk to each other, there's not a balanced view, a holistic view on how humanity can transcend and how humanity can go forward. And how is that connected to our talk? Well, I claim that as universities are based more and more on industry funding, yeah, which is big funding, funding for the humanities will drop. Because funding for all fundamental research in humanities is a sort of fundamental research. It doesn't give you tomorrow $1 profit. It will drop for all fundamental science, including humanities, But at least in our field, in the STEM fields, yeah, science and technology fields, we always get funding from these applications, and we can take some of it to do also fundamental science in our groups. But for the humanities, it will be the end. There will be less and less funding for fundamental science, and that would mean that also humanities will go down in funding. All the way to the point where I would not be surprised if universities start deciding to close departments in humanities. They don't bring in money. And I would not be surprised also if in our university, this will be the case. Some universities, like Weizmann Institute, already don't have humanities. All right, so the third thing I would like to note, that even if we leave humanities on the side and we focus just on exact science, things are still quite vague. Okay? We already noted that the connection, the role of universities is education and research. And education we already discussed, that traditional role, but even if we just look at research here, okay? What do we mean by research? We mean research for the benefit of humankind. That was the original goal of universities. Well, most people would say, if they had in one sentence to say research for what, they would say, my first goal, there's a list of goals. But my first goal would be, or definition or criterion, for the benefit of humankind. But what does it mean for the benefit of humankind? Okay? Is it for the benefit of humankind to have a better phone in 2 years? Much better than the phone I have in my pocket? Or is it for the benefit of humankind to explore the universe, to explore the possibility of going to other galaxies, or to explore the black hole in the middle of our galaxy? Now starts the big discussion, what is to the benefit of humankind? Okay? And of course the answer from industry is very different than the answer would be from philosophers, for example. Okay, so is it short-term or long-term research? So this is very vague, okay? I want to show you 3 examples of leaps that were caused actually for technology, that were caused in technology, but by fundamental science. So people who now say, I go back, people who now say, from the industry, they will say short term, of course, that's for the benefit of humankind. Better televisions, better cars, better iPhones, that's for the benefit of short term. And I claim it's long term, and I want to give you 3 examples for that. So the first one, of course, is the laser, okay? And there's a beautiful article that I found about the first years of the laser. And when the laser came, he claims here in the beginning, it was a solution looking for a problem. They didn't know what to do with it. Actually, somebody laughed at them, the scientist that invented the laser, and he said, actually, the only thing you can do with it is peel potatoes, maybe. Try it out. Try if you can peel potatoes with it. They were laughing at them. Yeah? No application. Now there's laser in everything. Okay, so this is an example of how fundamental science created a leap actually in technology. And I claim that this is actually the trend. And we have to, because of that, go for long-term research. Another example I want to give you is CERN. CERN is this big 27-kilometer accelerator underground in Genève. Actually, I did my PhD there. It was great. And it does just fundamental science. It's looking at quarks. It's looking at Higgs boson. These are things that will not have in the next 1,000 years any application. Who cares about quarks? For those who don't know, quarks are the particles inside the proton and the neutron that are inside the nucleus of the atom, inside the atom that you're built from. Okay? They have no applicative, but through this fundamental research, the scientists there developed things that are completely, nobody could think of these applications. They developed all the detectors, medical detectors that we now use, for example, to detect cancer. They were developed at CERN to detect all these particles, and they also developed all the tools that are now being used for radiation treatment of cancer. And they developed, for those who don't know, the World Wide Web. The internet was developed actually at CERN because there's thousands of scientists, they wanted some way to communicate between them efficiently. So many practical things came just from people thinking about quarks. Okay, that's another example. And the third example I'll give you, and there are many more, is Einstein. So, Einstein's general relativity, when it came out, he simply claimed, you know what? There's no gravity. Instead of gravity, he described it as curvature of space-time. So there's no force like gravity. He said everybody until Einstein thought that there's a real force. No, there's no force, just curvature of space-time. That's what Einstein said. People thought he was completely crazy. But definitely, everybody thought that there is no application to his thoughts whatsoever. Today, every Waze navigation that we use would not work without the GPS system having general relativity in it. Because general relativity is affecting the satellites, the timing in the satellites that are going around Earth. Nobody could have even imagined it when Einstein came up with his extremely weird and fundamental ideas. Okay, so these are, there are dozens more of, I just don't have the time, of great examples of how fundamental science leads to leaps in technology. Okay. By the way, always when I mention Einstein, I mention this book just for fun. This is a book that came out in the 30s, I think 1931. It says what, this is of course a translation to English that you can find on Amazon, but it was not written in English. 100 authors against Einstein. You know, Einstein's ideas were like completely ridiculous. By the way, 50s, 60s, 70s, even today, people are still fighting his ideas. It didn't end. Okay. All right. Of course, prominent scientists are putting up a brave fight, and I found this article from, I don't know, 15 years ago, when Daniel Zeifman, who I know is a great physicist, he was the president of the Weizmann Institute, and it says here he's busy building a wall to defend the academy against the industry, because that, he claims it would be a catastrophe if industry goes into academy. Okay? So a lot of people are trying bravely to build a wall, but as I claim here, the train has left the station. There is no way you can really fight it. What we need to do is balance, and actually I have even a more practical suggestion to just balance, and I'll show you it at the end. Okay, so I think I have to finish very soon. So at the end, I actually want to give you an advertisement. Okay? If you don't like an advertisement, just close your ears and eyes for the next 10 seconds. Okay, it's a short advertisement. So, the advertisement is about a hobby I developed, a strange hobby I developed in the last 10 years. It's not only strange, it's also dangerous. You want to know what the hobby is? So the hobby is, I started looking into theories of consciousness and possible connection to quantum physics, which is my field. So consciousness is my hobby, but connection to quantum physics, which is my field. And for the last 10 years, I've been reading what the scientific community, many different disciplines in the scientific community, maybe 20, 30 different disciplines are interested in consciousness. And I started to read all the papers that of these different disciplines that I could find. And it's very fascinating, and I say that it's still highly speculative, but I was surprised how many good theoretical and experimental work is already being done in this field of consciousness. So the result of that just came out a few days ago, and this is the result. It's a book that came out last week, and it's a popular level book, and I hope that you will enjoy reading it, called The Human Test. And that's it, so let me conclude. These are my take-home messages. So, first of all, our group is finding itself in the middle of a technology storm. It's really a hurricane. We are all the time being rattled. And I think that by now people counted 1,000 companies that were set up in the last 5 years. 1,000 companies just for quantum computing, which is just a small part of quantum technology. So hundreds of companies everywhere, including in Israel. That's one. So it's interesting from that perspective to look at the issue or the topic of this workshop. Two, it's important to emphasize the role of universities. It's education and research, but what do we mean by research? I think this is really the core of the question. And if people agree, at least that the first item should be for the benefit of humankind, that doesn't solve the issue, because we cannot agree, or most people will not agree, what does it mean for the benefit of humankind. As I said, short-term research, long-term research. High levels of industrial funding will eventually reduce funding for humanities. Governments and other agencies will say, you have enough money, we don't need to fund you anymore. But I claim that it will not only, it will reduce funding for any fundamental research, not only humanities, but also STEM fundamental research. Now is my suggestion. I said that the train has left the station, but we can do something about it, and that's what I started to do personally. I started to take a double overhead. So the university takes overhead from any grant we take for the electricity to run, for the water to run, air conditioning, and so on. But I claim that scientists getting a lot of money from the industry should take a double, nothing under the table, everything above the table, and the industry agrees. They have no choice. If they have no choice, they agree. So the second overhead is that the scientist takes that money and send it to fundamental research in the same research group. And there's a good actually rationale for it. I tell the industry that eventually this fundamental science will come back and help their applicative science. And so they understand that there is some rationale to it, and they agree to this second overhead. I would say that this kind of double overhead should become the rule in universities. Otherwise, we will not have money not only for fundamental research in STEM, but also for humanities. At the end of the day, focusing on technology will hurt technology. These are the three examples that I showed you. We have to keep fundamental science going, even just for the sake of technology. If we just focus on the next 2-3 years, a lot of technological leaps would not happen. And here you see a nice picture of how Israel, in journals around the world, they're talking about even Israel becoming a powerhouse of quantum technologies. And I thank you for your attention.
Thank you, Ron. That was a wonderful talk. And Anat Milo, one of the speakers, is not coming, so we have plenty of time for questions. I have a couple of them, very long questions, so I will leave first questions from the public. Ute, of course.
You can start. You can start if you want.
No, I want to finish.
Yeah, thank you, Ron. That was very, very interesting. And now I at least know what you are doing. Two things. One is, I said in my lecture that modern philosophy, postmodernist philosophy, also embraces technology, or feminism, postmodern feminism, feminists embrace technology. But of course that doesn't help them from being extinguished by the lack of funding. You know. But I found that interesting, so that doesn't help. And the other thing is I thank you that you clarified what you meant by benefit of mankind. That it's not just a better car, a better hairdryer, or better I don't know what, but it means also to have a better idea of understanding nature, of understanding your field, the universe, or the flowers, or I don't know what. That is very important to emphasize.
And that's exactly the problem, I think, of education coming from capitalism, because capitalism is trying to teach us that what is important is the very short term, the
Yes.
bottom line in dollars. And I think that while capitalism is a very important system for economy, for growth, so people will have food, it's a very important system. But I think that we have to balance it with a wider view of what we mean by benefit for humankind.
Right, but the same holds true for socialism, if I may say it. You may remember this Bukharin quote, that the benefit of mankind, it was that's what science should do. And basic science is something only for a class society. I mean,
Yeah.
whatever.
Yeah, sure. They're from all different political. It's not that I'm talking about capitalism in favor of socialism or communism.
is the same,
all-
except that their economy doesn't function. But
Yeah.
by on this aspect, also science wouldn't function. But they abolished it over there.
Yeah.
But in the first years, it was the motto also.
Yeah.
Well, thank you. I have a few comments to make, but the first one is maybe we should take your proposal and triple the overhead and move some to the humanities.
No, when I say double funding, I mean,
No, you described it in terms of going back to fundamental science.
yeah,
But maybe
that's
the
humanities.
circle could be wider.
yeah.
Reach
So
some of us poor guys.
the circle should be wider, but that's already a decision at the level of the heads of the university. See, until that takes place, that's a great idea, and I'm completely for it. But until that takes place, at least without approval from the university, scientists could do that within their groups.
Okay, now the other thing I wanted to say is that you have described research in terms of the benefit of mankind. And I was struck by the fact that you didn't mention truth. You didn't mention truth as the ultimate goal of research and the constraint that any benefit to humankind that scientists may bring about is to be brought about through and only through this search for truth, and not in any other ways. So maybe you want
Let
to
me just react to that. I love the word truth. However, it became baggage. Unfortunately, in this world it became baggage. So every time you bring up the topic of truth, you open up a whole can of worms you don't want to even go into because it just blurs the thing you want to discuss. So while I love the topic of truth, by the way, in my field, we don't talk about truth. We talk about, strengthened paradigms and words like that. We're very cautious with using the word truth. So I personally never use it in front of my students. Maybe there is some truth, and it's very far from us. It's infinitely complex. I don't know if we'll ever grasp it, but definitely we should work towards it. We should work toward getting closer to it. So the word truth right now is manipulated in so many ways, so many political ways. On purpose, I don't want to touch the word. But I agree with you. It's a beautiful word, and it's part of the benefit of humankind.
If I might add on the problematic nature of the word truth, truth social. That's a demonstration of the problematic nature of the word truth.
Yeah.
And so is pravda, which happens to have the same meaning.
So it's
Pravda, I don't know if you're of the word.
pravda. Yes, pravda.
Pravda and truth social both enjoy the word truth there.
Yeah.
Yeah.
Well, the manipulation of the word truth needs not eliminate our concerns
The guy who wanted
with truth. And I would just add that the benefit of mankind
public
is a can of worms.
Yes, you're right. So, choose your poison. I choose that poison, but I agree that it's maybe just as bad as your poison.
I have two continuous questions. The first one is, when you wrote it,
Can you speak up, please?
Again?
Can you speak up,
Yes,
please?
I have two continuous questions. The first one is very short. When you write a grant about quantum chips, do you include the application or the applicable side of it?
It's a great question. It depends which funding agency you're writing to. If you know that this funding agency is interested in applications, you will write about the applicative side. If you're writing to some typically to a funding agency that is typically very interested in foundational questions, in changes of paradigm, for example, then you would write about foundation questions.
And the second question is related to Jonathan talk about back to the ivory tower. So he discussed that the public doesn't have an interest in, dark matter or other things. They want a better iPhone into 2 years from now. So how do you relate to this from the academic perspective? Do you think we should change our questions, or we should explain the public more about the importance of this basic fundamental questions?
It's a good question. How do we connect with the public? My book is an attempt to do that in a popular way. There's even a love story inside that book, so I really went all the way to trying to get the public happy. But the bottom line is that it's important to get the public on board. And I would say that, just like with the funding agencies, your previous question, you have to know who your audience is. So if I would come to some club where I think the audience is mainly interested, or some high-tech company lecture there, where they're mainly interested in applications, I would talk about the quantum applications, I would talk about the quantum computer and so on. But, just to give you an example, I was in a conference last Tuesday. There was a cyber conference in Tel Aviv, and I was on a panel there. And they asked me, okay, they asked the whole panel, when will the quantum computer come? When? I thought it was too much. Everything technology, everything exits, everything, how much money are we going to make in a year? So at the end, I told them, okay, guys, all that is very nice, but let me tell you something new that you don't know about the quantum computer. And that is that the quantum computer, actually, I call it a worm factory. So everybody was, why is talking worm? We never heard the phrase. And I told them that the quantum computer works on entanglement. That's a phrase in quantum mechanics, and everybody understood that the quantum computer works so well because of entanglement. I don't have time now to explain, unless you tell me there is time, what is entanglement. It's a beautiful thing, but anyway, it's mind-boggling. I told them, and there's a theorem that says every time two particles are entangled, it curves space-time and opens a wormhole. In science fiction movies, you hear about a wormhole where you can get from one galaxy to the other in 10 seconds. Yeah, although it's hundreds of light years away, hundreds of thousands of light years away. So I told them that's why you should look at the quantum computer as a factory of worms. And they were all like, huh? And then, just to complete the issue, they were a little bit shocked. They said, look, the first thing I tell students when I teach them first course on quantum mechanics is I came to save you some money. They heard money, they said, the audience heard money, they were back on track. I said, why have I come to save you money? Because every time you really go into quantum mechanics, into entanglement, into wormholes in space-time, into the fact that a clock can be two places at the same time, superposition principle, all that weirdness. You don't need any more alcohol in your life. You don't need to smoke all kinds of weird things. It saves a lot of money. You're high naturally all the time. So then the audience got it. There's a lot of fun in knowing quantum mechanics. There's fun in knowledge without the dollars put into it. So I was able at the end of this panel just to give them a little bit of taste. So I think you can connect to the public on both levels. How it's good for them in 2 years, and how it will make them money and life easier and more efficient and blah, blah, blah. But I think there's also the way to show them that it's simply fun. It makes life much more interesting, much more fun if you know about these crazy issues and they go around traveling in your brain.
Hi, thanks. So I think if I understand you correctly, you're suggesting a model where there's basic science, pursuit of knowledge for its own sake, and then there's the practice or industry aiming for goals, practical goals. Now, it's kind of odd that you have been pursuing knowledge for its own sake without truth. That's kind of interesting on its own, because what is knowledge if not the pursuit of truth? But
No, I was not speaking against the pursuit of truth. Don't get me wrong at all. I'm just saying that right now the word, is a little bit temunah. How do you say temunah in English? Loaded. It's a loaded term with all the fake news and so all the deep fake and so I just don't like to use it, but I'm completely in favor of the pursuit of truth.
okay, so there's this in practice of basic science. I think it's an interesting empirical question whether your story is correct, that basic science leads to technology and whether there's no other direction. But even let's put that to the side. The thing I'm most interested in at the moment is this idea that there's this pursuit of knowledge which is value-free. Like you don't know what the application is going to be. But then you have this hope that it will lead to good, to the benefit of humankind. So, you know, there are many examples, or there could be, let's avoid the history, imagine cases where the pursuit of knowledge leads to very, very bad things. It might happen in the future. So you might think this pursuit of knowledge per se is not necessarily to the benefit of humankind.
That's our hope. That would be my criterion. My first criterion on the list of criterions. Yeah, the second one would be pursuit of truth, and more a list of criterions for what I would hope that fundamental science can lead to or will lead to. But what you're saying, how are we going to use this knowledge? And definitely how are we going to use the knowledge of atomic energy? Will it be for electricity, or would it be for the annihilation of humanity through weapons of mass destruction? We have no control of that, at least not a lot of control of that. So we can stop doing research, because we think that some of it is going to lead to bad consequences. We could do even, but that would not help, because other scientists will continue to do the research. You cannot stop knowledge from progressing. So I don't know what to do with your question, in the sense that, yes, everything we develop, even the quantum computer. For example, the quantum computer is going to crash our privacy. Really crash. So all the cyber techniques that today exist on the cloud, wherever you want, all the internet security that you have for your credit card, whatever, they're all gone. Gone. Privacy will be gone, so that everything you put on any kind of device will be hacked into, unless of course there will be attempts to fight it. There's always some balance. But so quantum computer could be used for very bad. Does it mean we stop developing it? It could also be used to develop new drugs. And it will have a leap in development of new drugs, because it can calculate for the first time how molecules fold, complex molecules fold, which means how they actually bond to other molecules. So the first time we'll be able to design on the molecular level excellent drugs. So now, what do we do with that? I don't know. So the only thing I can think of is developing through education ethical norms, so that the future generations don't use the technology we developed for bad. I really hope that will be the case, but you never know that in advance.
Well, I guess the idea is, if you want to describe or identify basic research, and you want to leave those out, then maybe it's better not to describe it in terms of the benefit of humankind, but rather the pursuit of knowledge per se, or something like that. That seems to be more.
If one day, that would be my criterion. Each one has his own taste, personal taste. But benefit for humankind, I hope that everything we do will be for the benefit, including as researchers, will be benefit, with the thought that it would somehow be for the benefit of humankind. At least that's how I work. But it's maybe a personal thing, so pursuit of truth could be stronger for some people. Knowledge for knowledge's sake could be stronger, or curiosity for some people, but for me, I really think that the situation of humanity is so bad that everybody should really have that as their first goal, whatever they can do to benefit humankind, or to somehow help humanity transcend to a better place. I think each individual in the 7 or 8 billion people that live on Earth should have that as their first criterion. We're very far from it, and even as a scientist, I want this to be my first goal. But of course, I acknowledge that I'm not sure if the knowledge I develop will be used for good or for bad. I have no control over what other people do with it. So it's a very complicated question, which I don't have a good answer to.
We have to stop.
We don't have much time. Very fast question.
It's a bit provocative question maybe, but
Provocative is good.
when we talk about the value of science for humanity for society. So yes, we have this excuse, which is the technology. We know enough about the world in order to use to exploit the knowledge, but the knowledge is not complete. So we want to make it more complete. But on the other hand, we have a thing to compare ourselves maybe, and it's a joke with me and other friends that are PhD students in humanities, that we are avrechiot. So there is this knowledge project with the yeshivot, which is also funded by the government. And we ask, what do they give for them? They give us, the society, a great value because they please God, or I don't know. Maybe some people will say that they maintain the heritage of the Jewish knowledge. There are many reasons, but for us, as part of the academia, our biggest excuse is that is the technology. So I wonder.
And not for me. By the way, I don't agree. Many scientists that you would ask, they say technology is the last on their list of motivations. And also for me, it's quite far down there.
So once somebody asks you, you just spend a whole day reading about black holes and trying to think how your research provide new knowledge for this realm. I don't see any benefit and technology comes out of it. What is the difference between you and the yeshiva student that just spend the whole day thinking about the Rabbi X, I don't know?
There's a huge difference, at least in terms of the proven, again, empirically proven benefit for humankind. And that is, I started with 3 examples, but I can give many more examples of fundamental research. At CERN, the laser that was a solution waiting for a problem, and I gave another example, the general theory of relativity that is now doing the GPS. There are hundreds of examples where far-reaching fundamental science gave benefits for humankind. So it's very hard to come after all these hundreds of examples in the last 100 years and say it's the same with the yeshivot. The yeshivot do not have a single empirically proven. They can claim as much as they want that they helped humankind, but they don't have a single empirically proven benefit that they gave to humankind. Empirically proven. So that's the point. The whole point between these 2 realms of society is that one focuses on things that are empirically proven, and the other says, I don't need empirical proofs.
And what about the metaphysical discussion?
Well, metaphysics is outside science. That's why it's called metaphysics. So metaphysics goes into the realm of no empirical proof. Even, by the way, inside physics, this is tension all the time. For example, people talk about string theory. String theory right now has 0 empirical proof. It's just very beautiful mathematically. So people are continuing to work like mathematicians on it, although they're in a physics department. But you know, there's a guy, a friend of mine, that is doing string theory. It's extremely fundamental. And he comes and, Ron, you want to hear our latest? I said, are you able to calculate anything? The mass of the electron, the interaction of the proton, anything? He says, no. When you can, I'll come and hear your lecture. So for me, this is the border between metaphysics or whatever you want. By the way, there's a lot we don't know. I don't want to sound as if we know everything. No, definitely. There's tons. We know this little. There's tons that will be discovered, but we have to continue with the rule of proven empirically. If we abandon this rule for metaphysics, for whatever else ideologies, we are going backwards. So as we have to keep to that rule, and as I said, even fundamental science has by now hundreds of examples empirically proven of how it benefited humankind. And that's a difference.
Okay, so I will make just a short comment hidden into the questions.
Into a question.
First of all, I love the idea of double overhead.
So before we suggest triple overhead, we'll suggest double. Maybe it'll go better.
Yeah, yeah, 4 times.
Yeah.
Now, I understand your point, your whole point, and I'm in favor of it, but I think you are falling into the survival bias. You are giving the examples of the things like the nature, like relativity, the things that with time they were proven to be really worthy.
Yeah.
Of course, the laser, you have a laser in your hand. But that's survival bias. Most of science, of basic science, doesn't work, nobody will care about it in 2 years. There is I really like the Sturgeon's law that says 90% of everything is crap. So you have to have a balance when you're saying, that's my comment, right? And the question will be, what do you think about that? But you have to balance a bit on this idea of science will have some useful, very useful purpose in the future. Most of science.
This was not my criterion. Again, this was not my. I never said that because we don't know. So I never said that that was not the criterion. I said the criterion I would like to choose is benefit of humankind, but I put it in a question mark. What is benefit for humankind? I left as a question. So for me, knowledge for the sake of knowledge is a great benefit for humankind. Yeah, just curiosity is one of the great traits of humans. So just pure curiosity. So perhaps I was not fully clear, but there's a question mark at the end of what is the benefit, what do I mean by benefit for humankind. I think it would be very hard for people to reach a consensus. And for me it's not clear, but I definitely don't judge the science that I do by trying to think what kind of technology it will bring in 20, 30 years. No, many things I do are, I have no idea what kind of applications they will bring 20, 30 or 3,000 years. I do it for curiosity, I do it for fundamental science, I do it for knowledge for the sake of knowledge, and that is my main motivation, and that is what keeps me high, as I said. I don't need cigarettes or alcohol, that's what keeps me high. So if I was not understood, I would like to clarify that my motivation is not technology in any sense, not even technology that will come in 20, 30 years.
Okay, thank you very much.